Yeah, so I just start. Guys, you can disable your videos, okay? So I'm also. Okay, now, yeah, so the first thing, guys, you all have access to Moodle, right?
Yep.
So then, yeah, so if you go to this home page, there you can find the module outline. Can you guys please download the module outline? Yeah, just browse through the content of this module. Okay?
Outline.
Yeah, that's correct. Module outline. So you should find it on the home page.
Yep.
Just load that document, open that document, and see what are the module content.
Okay. I think I printed this already.
Yeah, guys. Now you guys can see my screen, right?
Yep. I can see your screen.
Yeah. Okay. Okay, guys. Here you can find my contact detail and coordinator details. So here these are the basic outline, right? So basic content of this module. So we are discussing about DC circuit theories, Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law, things like that, and also capacitors, transient behavior of capacitors, electromagnetism, so inductors, so transient behavior of RL circuit, and then after that, like AC circuits and RC AC circuit, RCL AC circuit, RL AC circuit, likewise. Okay. Then after that, so we will be discussing about power in the circuit and also three-phase electricity. These are the basic content of that. Okay. So then if you look at the assessment, there will be 2 lab works and also, yeah, 2 lab work and also 1 assignment, and there will be 1 class test. Okay, these are the basic assessment components of this module, guys. And also you guys familiar with the blog course date, right?
Yep.
Yeah.
Did I send you the detail about blog course?
I got that in the email.
Okay, that's great, guys. Okay, so then you guys can plan according to that. Where are you from, guys? Both of you around Hamilton, or?
I'm in Benham, the South Island.
Okay.
I'm in South Island as well, down in Balclutha.
Okay, in that case, guys, yeah, so maybe you need to arrange flights during this blog course. First blog course, I think it is only 1 day. Second blog course, we have 2 days. Okay.
Yep.
And now also when you guys sitting for exam, so you guys can do it in your workplace or somewhere. You need to forward us like your supervisor detail. But anyway, guys, if you guys coming for the second blog course, I think dates are aligned with exam date as well, I think. So in that case, you can stay and so face your exam here. But you have the chance, guys, so you can sit it in your places as well.
Sweet. No, I'll probably do it there.
Okay.
Yeah, I think I'll come down as well.
Okay, so yeah, it's up to you guys. Okay, so that's good. Okay, guys, these are the basic thing. So there are a lot of materials on Moodle. Mainly, guys, when I'm teaching this distance course, what happen is I'll work out these problems, activities, things like that. Okay, so we are not spending much time on browsing the content. Okay, these things you guys can leisurely read. Likewise, mainly I'm helping you with your exam. Okay.
Fair
And
enough.
one important thing, so paper for this module, that is not local WinTech paper, it is a national paper, okay? So you need to mindful about that one also. Because of that, you need to put some effort to pass the module. So if you attend all the video classes and blog courses, I think generally you will be okay. Because so my past experience, even last electrical principles module and also electronic principle module, so the distance class, it is almost 100% pass, okay? But
Sweet.
I have difficulty in the regular class, so here the pass rate is not that high, like it is around 60% in internal courses. But because we are thinking like distance students are more focused, matured, and responsible, because of that, maybe they manage to pass the exam, and not only just passing, so they get good marks as well. So that is my past experience. I hope two of you also will conveniently pass this module.
I sure hope so.
Okay, so
Yeah.
I hope that is enough the background. Today I have small activity uploaded, so we'll go through that one. Okay, if you guys can go to assessment, under that assessment, guys, you can find activity. Just see activity 1. Just see whether you guys can see.
Assessment,
If you go to,
activity 1. Yeah.
yeah, okay.
Yeah, activity 1.
Okay, I'll also open that one.
Ooh.
So
You
you
just
can,
put this up recently.
yeah, I think I put it recently.
Okay.
Guys, yeah, thing is, okay, so you all can see my screen, right?
Yep, yep.
Yes, yes.
Okay, guys, I extract all these questions from past exam papers. Okay,
Okay.
so generally, you first exam question that is from Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law, from these areas. Okay.
Yeah.
Okay. Now read the question 1.
Refer to the circuits in figure 1.1 and 1.2 and explain how these circuits demonstrate Ohm's law.
Okay. So what is Ohm's law, guys?
I don't know.
Sorry. You guys have learned,
V
I
equals
think.
IR.
Yeah, that's correct. Very good. So in a conductor, okay, when we have voltage potential difference across this one, this potential difference of voltage directly proportional to the current of that conductor. Okay, so in other terms, we can say like V is equal IR. Okay.
Yep.
Yes.
So we can rearrange this equation to find current. Current is equal V divided by R. You guys agree?
Yeah.
Yep, yep.
Okay, so if you want to find resistance, R is equal V divided by I. Okay.
Yeah.
Okay, in that way, so these are different versions of the Ohm's law, right? Now, in these given circuits, how we prove that they follow Ohm's law?
Well, times the current by the resistance.
Yeah, very good. Yeah, we can just substitute these values to V equals IR equation formula. Then we can validate those values. And if they follow that rule, so then that they are following the Ohm's law, right? Okay. Yep. So just see, guys, case 1, whether it follow the Ohm's law.
Yep.
See, if I apply, let's say V is equal IR. Okay. So then I mean 2.5 multiplied by 2 10 to the power 3, because it is kilo ohms, right?
Yep.
Okay.
That's milliamp, wasn't it?
Yeah, that's correct. Yeah. So this is milliampere, right?
So that'll be
yeah. So that means 10 to the power negative 3.
Minus 3.
Yeah,
Yes.
yeah, that's correct. Yeah. Or maybe, yeah.
These two cancel.
So
that's about 5 volts.
Yes, so if I write it here, V is equal IR. So then that is equal, I is equal 2.5 10 to the power negative 3 multiplied by, so what is our resistance?
2
10 to the power 3, right?
10 to
So
the power
then
3.
these two terms I can cancel, right?
Cancel them, yeah.
2 multiplied by 2.5, so that is
5
5
volts.
volt. That means if you look at the circuit, so it is 5 volt, right?
Yeah.
That means this follow Ohm's law. Same way, if you substitute these values, you guys can prove this is also following the Ohm's law.
Yep.
Is that clear, guys?
Yes.
Okay. Now after that, we'll move to this question 2. So now here, guys, tell me, guys, so when we connect resistors like this in series, what will be the total resistance?
R1
here,
plus R2 plus
yeah.
R3.
Yeah, very good. Yeah. So when we connect them in series, total resistance that is equal R1 plus R2 plus R3. You guys agree, right?
Yeah.
Now, second case, now think I connect these resistors like this. R1, R2, R3. Okay. Now what will be the total resistance in this case?
1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3.
Okay, it's something like this. Okay. If
So,
it is RT, 1 over RT is equal 1 over
R total
R1 plus 1 over R2 plus 1 over
R3.
R3. Okay. In
Yeah.
other words, I can write it like, yeah, so I'll clear this one.
So
In other
R1
words,
plus R2.
R total is equal 1 over R1, 1 over R2 plus 1 over R3. You guys agree with this one?
Yep.
I just took the reciprocal, okay? Because 1 over RT is equal 1 over R1 plus likewise.
Yep.
Because we to take RT, R total, we need to take the reciprocal of that, okay? So then that means 1 over whole thing. So now this is how we find. You guys okay?
Yep.
Okay, great. Okay, good. Now, guys, try to solve this one, okay? Try to solve this one. Now here, what happened? Calculate the current through the resistor R2. So we need to find current through resistor R2. Just see how we can solve it. Take about 5 minutes, then I will explain. Okay, guys, any idea?
Yeah, I'm not
First,
too sure.
Yeah, first thing guys, when we get some network like this, we need to simplify this. Okay, so here you can see two resistors. Okay, so this means it is 6 ohms, right?
Yep.
So now
3 plus
3
3.
ohms. Now here also we can say it is 18 ohms. Okay. Okay. Now guys, when you add these 3 ohms and these 3 ohms, what will happen? What will be the total?
2.
Very good, 2 ohms. Because it is 6 divided by 3, right? So
Yeah.
because, yeah. Or maybe in other terms, we can write it like 1 over 6 plus 1 over 3.
1 over
When you
3.
simplify this one, you will get it is 2 ohms. Okay. 2 ohms. Now here the total is 2 ohms. What is the total resistance of the circuit?
20.
Yeah, 20. Very good. So then this circuit can be reduced to some circuit like this. Okay. So this is 20 ohms. So this is 24 volt. 24 volt.
Right.
You guys agree?
Yeah.
Okay. So now what is this I, guys? So that is not known. So how we find the current value?
It's 24 volt divided by 20 ohms.
Okay, so that's correct. I is equal 24 divided by
No.
20, right? So that means what is the value?
1.2.
Very good. Okay, 1.2 ampere. Okay, now so what we need to find is current through R2. That means let's say that is I2. How we find that current? Now we know the current through whole circuit, right? But we don't know how much current flow through this R2 branch. So how we find that current?
So IT is equal to I1 plus I2.
Hmm. One thing, so you can find voltage between these 2 points. Let's say that is A and B. Okay, how we find the voltage between those 2 points? So what is the total resistance between this A and B point? That is 2 ohms, right?
2
Because
ohms.
we now we know the current. Can we find the voltage between these 2 points A and B? V is equal IR, right?
Yeah.
So that is equal to multiplied by 1.2. So that is 2.4 volt. You guys agree?
Yep.
Okay, now that is 2.4. Now, because we know this voltage, can we find the current through R2?
Yes.
Yes.
Yeah. Then I is equal V divided by R, right? So that means V is equal 2.4. 2.4 divided by 3. Agree? 0.8 ampere. You guys agree?
Oh,
Guys,
you
is it
first
clear to
use
both of you? Yeah.
first you use the I total,
Uh,
the current that we did before, yeah, 2.4
yeah.
to find that. Okay.
2.4 is the voltage, right?
Yeah.
Voltage between AB point. We calculated that one. So once we
Right.
calculate that one, so we can easily find the current through R2 branch, right?
Yeah.
Okay, good. Now, if that is clear, guys. So, guys, you have any question, guys? Both of you, okay?
Yeah, I'm okay. I'm okay.
Okay. Okay. Now, try this one for the circuit shown in this figure. Calculate. Okay, what we need to calculate here? So that you need to find R2 and power dissipation through R2. Okay, resistance, that means what is the value of R2 and also power dissipated by R2. These two things you need to find. Okay.
Other questions. Resistance of R2. Power distributed by.
Okay, guys. Now you guys got the answer. Okay, so this is how we solve. Now the voltage drop between these 2 points that is given, right?
Yeah,
Yeah.
yes.
That is 1 volt.
1 volt.
So then what is the voltage drop across these two?
It should be 11 volt.
Very good. Yeah, total it should be 11 volt. Okay. So these two, that is 11 volt. Okay. So what will be the total of R1 and R2? So
It's,
yeah, R1 plus because they are series, I can write R1 and R2 110 kilo ohms. You guys agree?
R1 and R3.
Sorry, yeah, R3.
Yeah.
That's correct. You guys agree?
Yeah.
Okay. Now, what is this one? V R1 plus R3. The voltage drop between these 2 points, that will be 11 volt. Okay. So
Yes.
then, okay. So can you guys find the current through the circuit now? Let's say it is I. What will be I?
11 divided by 110.
That's correct. Yeah. V divided by
ohms.
R, because this is the total voltage drop, divided by resistance, right? So then that is equals to 110. So that means, guys, what will be the value?
It's point 0001.
Hmm.
1, 2, 3, 4. Hmm?
0001. Yeah.
Yeah, that's correct.
1 times 10 to the power minus 4.
Yeah, that's one.
That's correct, guys, right? 0.1
Yeah.
ampere.
0.
Okay.
I thought it was that because it's kilograms, isn't it?
Yeah. That's what I did as well.
Guys, you all agree? So that is
Uh,
11 volt divided by 100.
Oh, where did you put the kilo ohms?
Yeah, sorry. So like it should be milliampere. Yeah, that's correct. 10 to the power 3. Okay.
Yes.
Milliampere, right? 0.1 milliampere.
Yeah, that's correct.
that's the one.
Okay, that's good, very good. Yeah. Okay, now if that is 0.1 milliampere, now can you guys find the resistance R2? Because guys, now you know the voltage drop and you know the current. So you can easily put these two figures into Ohm's law and can calculate the resistance, right? R2 is equal, B divided by I. Okay, so that means P is given, that is 1 divided by 0.1 multiplied by 10 to the power negative 3, right? So that means 1 divided by 1 multiplied by 10 to the power negative 4. Okay, you guys agree?
Yep.
So then the resistance is
10 kilograms.
10 kilo ohms. Very good. Yeah,
10.
that is the answer. Okay, 10 kilo ohms. Now in that way you can find what is R2, that is 10 kilo ohms. Now second part, we need to find the power dissipation, right? How we find the power dissipation? What is the equation for power dissipation?
VI.
Yeah, very good. P is equal VI, right? So now do we know this V and I for R2?
There we go.
Yes.
It is 1
1
multiplied
volt
by
times
0.1 10 to power negative 3. Okay, so that means 0.1 milliwatt. You guys agree with this?
milliwatt.
Yeah, milliwatt, 0.1 milliwatt. Agree? guys?
Yeah.
Yep.
Okay. So in that way, we can solve that problem. Okay. Okay. Okay, guys. Now we'll move to the second. Okay, the fourth question. Yeah. What you guys think? How we solve this sort of thing?
Question 4.
First thing, guys, you need to simplify the circuit. Okay. So this gray area you need to simplify. Tell me, guys, how you simplify that one?
Yeah. 1 over 3
Hmm.
plus 1 over.
Let's add R4 and R5
Hmm.
because they're in series. 4.7 plus.
R4 and R5 it is series. Okay.
Okay.
So you can just add them together.
Yeah, that's 8.
Yes. Correct. Yeah. These two, it is 8 kilo ohms, right?
Yeah.
So then we have two parallel, that is 8 kilo ohms and also 12 kilo ohms. In order to find that total, so that R is equal 1 over 8 plus
1 over 8.
1 over 12, that is kilo ohms, right? So what will be that value?
$4.8.
Yes. Very good. That is 4.8 kilo ohms. Okay.
4.8.
Yeah, 4.8 kilo ohms. That is the one. So now, guys, you have simplified circuit. Okay. Now, in order to solve this one, so you need to have knowledge on this Kirchhoff's current law and Kirchhoff's voltage law. Okay. I will give you guys like be 5 minutes. Just do a little bit of research and tell me what is Kirchhoff's current law, what is Kirchhoff's voltage law.
It is current law.
Let's see. Hello. Okay, guys, you found what it is?
Yep.
Okay, what it is? What is
Uh,
Kirchhoff law?
The voltage law is well, in a closed circuit, the sum of any given voltage is equal to 0.
Mm-hmm.
And the current law is the total currents entering a circuit junction is exactly equal to the total currents leaving the same junction.
Okay, very good. Yeah. So Kirchhoff's current law. So when you look at one node of the circuit, okay, something like this. So if you add all these incoming current together, it should be equals to outgoing current. Okay, that means this junction can't invent current. It is all about the current flow into the node will flow from that node. Okay, so that is the idea. For example, if I write I1, this is I1, this is I2, then I3. So what is the relation between these three current value? Incoming
I1,
current, that is I1, right? I1 should be I1 and I2. These are the incoming value. Should be equal I3. Got it?
Yes.
Yep.
Yeah. So that means it's a balanced system. Incoming current should be equal to outgoing current. Okay. Now, what is this Kirchhoff's voltage law? Like, if you consider any closed loop of this circuit, it can be this closed loop, whatever it is. When you add all voltage drops and rises, that comes to 0. Okay, voltage drops and rises, then that comes to 0. Okay, guys, now I will solve this network by using Kirchhoff's voltage law and Kirchhoff's current law. Okay, so then in your exam paper, this is actually a definite question. You are getting this type of ladder circuit, you need to solve that. Okay. Before that, there's one important thing, I think, guys. Can you all see, guys, under this assessment, lab 1? Can you guys see lab 1? Just download that file, guys, because there we have question from Kirchhoff's current law. So if you do that first, yeah. So I will also download that one. On the assessment, if you scroll down, you will see your labs. Okay,
lab work 1.
lab work 1. Okay, that's correct.
Lab work 1. Okay.
That's correct. Yeah,
The PowerPoint.
that's correct. Okay.
It is a PowerPoint.
Yeah. Then I will share that one. Yeah, lab work 1. Okay, we see. Yeah, you guys can see this one, right? Now I'm referring to this question, guys. Okay. Now if you look at this question, so here you can see circuit. Okay, in this circuit, some current values are given. Now, some are unknown. Okay, you need to find this current value. Yeah, this one and this current value, what they are. I will give 5 minutes, guys. Try to solve this. All you need to do is apply the Kirchhoff's current law. Okay. Okay, guys. So what is this value? U4.
2 amps.
Very good. Yeah, because very good. That is 2 amp. Reason, this direction also matters, right? So the
Yeah.
way we connect this ammeter, this side plus, this side minus.
Minus.
Okay.
Yes.
So this value positive mean current direction is this one, right? Positive to negative. Okay. Okay. Then this is 6, and it is given. This side is positive, negative. This is positive 4. That means, guys, current direction is 4, like this. Now, if you apply Kirchhoff's current law to this junction, you can see that. So there's incoming 6 ampere current, but this side it is only 4. That means there should be definitely this side it should be 2 ampere current flow, right? So because of that, answer to this one it is 2 ampere. Very good. Now what will happen in this case?
Same thing, 2 amps.
Okay, the magnitude is 2, but tell me whether it is positive or negative. Because guys, see,
Negative.
now,
Yeah.
yeah, very good. Yeah, it is negative. Now this side we have 4 ampere current, okay, and this side we have 2 ampere current flow, positive to negative. That means this side 2 ampere. Then what will happen to the rest of the 2 ampere current? So that should flow through this one, right? This is the direction, okay. But here you can see the direction of this ammeter. This is negative, this is positive, right? So then current flow happen from negative terminal to the positive terminal. That means, guys, it is in opposite orientation, right?
Yep.
So that means this should be negative. In indicating direction correctly is important, okay? So now this should be negative 2. Then that means we have 2 current ampere flow here, and from this side, so we have 2. So then when we add them together, we can see this side we have 4. That means correct, right? We have the correct answer here. Okay, now you guys clear about this problem and also Kirchhoff's current law?
Yeah.
Yeah.
Both of you okay? Okay, that's great. Okay, now we'll move to our previous question, okay? Okay, this is our question.
These labs we have to do and send it in, or?
Yeah, that's correct. Like when you come for the block course, you can do it during that time.
Oh, okay.
Okay. Okay, now guys, I will redraw this circuit because now we simplify this gray area to 4.8 kilo ohms, right? Correct?
Yes.
Okay. Now that is so, guys. Yeah, I will redraw this one by simplifying. Okay. Okay. Now here we have this resistor. This one it is 3 volt, okay, and we have one resistor like this. This is 2 kilo ohms. This is 3 kilo ohms. This is 9 volt. Then this is 4.8 kilo ohms. Okay. Is that correct, guys?
Yep.
Yes.
Okay, good. Then when you get question like this, first thing that you need to do, guys, you need to mark direction of the current. Okay. So when I look at it, guys, I feel okay. So this side current is this direction. Okay. this side current is this direction, because generally current flow from positive terminal to the negative terminal of the battery, right? I will say this one is I1, okay. This one, so I will say it is I3, okay. So then, because both of them come in like this, I think I assume this current is this direction, that is I2, okay. You guys okay with this one?
Yeah.
Okay. I just mark the direction of current, this I2 direction, guys. Even we can mark it to opposite direction. Even any of these value, we can mark it to opposite direction. It is not wrong, but when you mark it to opposite direction, you will get negative answer, right? That's all what happened. So there's no right direction like that, okay? But generally, because when you look at the orientation of the battery, you can decide, okay, current is from positive to negative terminal. Because of that, in this 3 volt case, it should be this direction. Likewise, you can assume, okay. Is that clear, guys, up to this point?
Yep.
Yeah.
Okay. Now next point, you need to indicate positive and negative terminals of each of the component. Battery, this is positive because it is obvious, it is given, okay. Then current flow from this direction, okay. If you look at this 3 kilo ohms resistor, what will be the positive terminal? So bottom one and top one.
Bottom.
Very good. Because current flow happened from positive to negative.
Positive
Okay,
to negative.
like
Yeah.
okay. What about 2 kilo ohms? Right hand side or left hand side?
Right hand side.
Yeah, right. It is positive because
Right
current
hand
flow.
side.
Yeah, this is negative. Same way, mark positive and negative terminal in the second part. Okay, so this is positive, this is negative. That is obvious. If you look at this 4.8 kilo ohms resistor, which one is positive terminal? Top or bottom?
Top.
Very good, top. So, okay, now in this way we mark positive and negative terminal. Now we will okay. Now here we have 3 unknowns, I1, I2 and I3. To solve 3 unknowns, how many equations we need?
3.
Very good. Yeah, 3 unknown, number of equations should be 3. Minimum we need to have 3 equations. Now we will derive some equation to solve this problem. Okay. First, we will apply Kirchhoff's current law to this node. Okay. When you apply Kirchhoff's current law, you can see, guys. Okay. I2 is incoming current, or maybe yeah, sorry. If you look at this one, one is outgoing, right? Or maybe just it is easy, guys. Look at this node, okay? It is easier to solve this one because we have marked, yeah, I1 and I3 incoming current, right? I2 outgoing. You guys agree?
Yeah.
Okay, so then what is the equation there? I1 plus I3
I3 equals I2.
should be equal I2. Okay.
Right.
Agree?
Yep.
Okay. Now I will rearrange this equation like this: I1 minus I2 minus plus I3.
Plus I3.
Yeah, should be equal 0. That is my equation 1. You guys agree?
Yes.
I1 minus I2 plus I3 should be equal 0.
Yeah.
Okay. Now, next thing, guys, apply Kirchhoff's voltage law to this loop. Okay. So here you can find closed loop circuit, right? Then when you add all voltage drops and rise, it should be equals to 0. Agree?
Yeah.
Now, when you look at this battery, negative to positive, if you look at this green color arrow, negative to positive, is it voltage drop or rise?
Right.
Negative to positive is rise.
Very good. Yeah, negative to positive, it is rise. Because of that, we will say, okay, 3. Then go like this in the loop. Okay. when you come to 3 kilo ohms one, it is positive to negative. Is it drop or rise?
Drop.
Very good. So because of that, drop should be negative.
Yeah.
If you think rise as positive, drop should be negative. Okay. Okay. Now 3 minus 3000, we need to convert it to ohms. 3000. What is that voltage drop? 3000 I2. You guys agree? It is just the Ohm's law, right? V is equal IR. Okay. Instead of writing that voltage drop, I write 3000 I2. Agree?
Yeah.
Okay. Then come to 2 kilo ohms one. Again positive to negative. Is it voltage drop or rise?
That's drop. Yeah.
Drop.
That means negative. 2000. Current is I1, right? I1 should be equal
Currently
0.
I1.
Okay, should be equal 0. You guys agree?
Yes.
Okay, now I will rearrange this equation. 2000 I1 minus, yeah, 3000 I2 should be equals 3. That is my equation 2. You guys agree?
No.
No,
With the
it should be-
minus sign on 2000
Yeah.
I1.
So
Yeah,
yeah,
should be
this should be
plus.
positive, no? This one also positive. Because just think, guys, I'm taking these terms to right hand side. Okay.
Yes. Okay.
Now is that okay?
What is equal to? Yes. Yes.
Okay.
Now it's okay.
Okay. Very good. Now do the same thing to second loop. Here also, guys, you can identify loops like this. Okay. That is also closed loop. Now we'll write starting from the battery. Okay. So that is negative to positive. That means voltage rise, right? I write that line here. So when you come to 4.8 plus 2 minus, is it rise or drop?
Yeah. Drop.
Drop. Because of that minus 4800 I3. Agree?
Yep.
Again, when it comes to 3 kilo ohms, is it positive to negative? Drop or rise?
Drop.
Very good.
Plus minus.
3000 I2, right? Should be equal 0.
At so 9 volt is equal to
Okay, guys?
Yeah.
Now, I will rearrange that equation. 3000 I2 plus 4800 I3
equals
should
to
be
9.
equals 9. You guys agree with that one?
Yeah.
Okay. Guys, if you look at these three equation, 1, 2, 3, if you solve these three equation, we can solve this circuit. We can find what is I1, I2, and I3. Okay. For the moment, by using calculator, I will solve this one. Okay. So if you all have this Casio calculator, guys, you can go to equation mode. There you can feed this equation in matrix form. Okay. So then you can get the answer. Next week, guys, I will explain how to solve this one as well manually. Okay. Generally in exam, what we worry about is you need to have right equation and right answers. Then you are getting full marks. Is that clear?
Yeah.
Okay. So now I quickly feed this equation to the calculator and tell you the answer. Okay. So Guys, these are the values that I'm getting. I1 0.12 milliampere. Okay. I2 that is 1 milliampere.
1.0.
Yeah. So 1.08 milliampere. No? Then I3, what I'm getting, very good, 1.2 milliampere. Okay, these are the answers, guys. You guys tried those?
I was gonna try to do it manually.
Okay.
See if I
Got
can
the same
figure it
answer?
out. Oh, I haven't done it yet. I was gonna go soon.
Okay. Okay, guys, these are the answers. I'll double check my metrics. Yeah.
Again.
One,
One,
maybe
one.
1, 0, then 2000, 3000, 0, 3, 7, 0, 3000,
0 equals to.
Yes, guys, these are the answers here. Okay, now, yeah, guys, my I1 is, it is negative value. I haven't put the sign. It should be negative, okay? So why it is negative, guys? That means because here this 9 voltage source is bigger. Because of that, current flow from this side, okay? That is the idea.
Yeah.
Even though we assume it like this, actual current flow is to opposite side.
Yeah, that's why it comes out negative.
Yeah. So then, if you guys solve this equation, you will get same set of answers. Okay.
Yeah.
So, guys, is that enough for today?
Yeah, that should be good.
So maybe I will upload this video tomorrow or day after tomorrow. So maybe I will create new tab as like Zoom. So there I will put those videos. Okay, you guys can watch them and also revise what we discussed today. So if you guys okay with the things that we discussed today, so then you can easily do first question in your exam paper. Actually, today's session I target with that first part of the paper.
Sweet.
Okay. And also you can find many past exam papers also, so you can download them and try these questions. And answers also available, guys. Okay.
Okay.
You guys enjoyed the class, like the way we deliver it and things like that? Any comment, guys?
Yeah, that was good.
Yeah,
okay.
It was good.
If there's anything, let me know, guys. I'm flexible. Okay.
Sweet.
Okay.
Thank you.
Okay. So then enjoy the rest of the day. Thank you very much for joining. Yeah. Good
Thank
night.
you. You too.
Sweet.
Okay.
Catch you later.
Bye, guys. Yeah.